Welcome to day 8, Understanding Actions in Spark. By now, we have written a fair amount of Spark code. We have selected column, we have filtered, and we have learned something called with column to add a new column. But here is a curious detail. Spark hasn't done anything yet. It sounds strange, right? We first typed a command. Spark should execute right away. But answer is no. And understanding the reason behind it is a is a key to becoming a confident Spark data engineer. Why Spark waits? Spark follows what we call is a lazy execution model or lazy execution model. When you type something, it doesn't execute. Let us understand that with code. We are back to our sales.csv. So what we are doing is we are creating a data frame with spark.read.option and spark.read.csv. Basically spark.read.csv, we are reading our sales.csv and creating a data frame, and then we are filling all the missing values with 0. Let us try to execute this. The moment we execute this, we see that nothing has happened, uh, only the code is executed, correct? But then when we call df.show, we see that the data is returned. On the similar lines, let's move ahead and perform some transformation with column. We took the data frame from the previous execution and added a column called revenue with tax. Let us execute this. Again, nothing happened. Now let us call df2.show and you should be able to see the result after that. What has just happened? To understand this, let us first understand some of the basics of what is Spark execution model. Spark execution model works like this. So the moment you perform any kind of SQL operation or any data frame operation for that matter, what happens is Spark would prepare an unresolved logical plan. Whenever a data frame action is performed, it would prepare an unresolved logical plan. Then it would create a logical plan. Then optimizers would trigger in and they would optimize the logical plan. And then finally, a physical plan is prepared on which cluster to execute, how many clusters are available, and all that. Once the physical plan is prepared, a cost model is derived, and the best cost model is selected for physical plan execution. Even at the cost model layer, the theory says that it prepares multiple cost model and it will only select the one which is having the least cost. And finally, a physical plan is executed. So what happens during this entire process is a plan is being prepared continuously. So Spark doesn't immediately start crunching the numbers. Instead, it quietly makes a note of its plan. If I am ever asked to compute a data frame, how would I take the original data? How would I add columns with how would I add a new column uh, and then return the result? This is similar to how an architect works. Let's compare it to the real world analogy. Imagine that you tell an architect that I wanted to build a house, I want this type of bedroom, and I want that kind of things to be built. The architect doesn't go and immediately start laying the bricks for you, correct? Instead, they add the detail in the blueprint. They keep on iterating over it, and then once the things are finalized, they start their execution. Spark almost does the same thing. It creates the blueprint of the transformation but waits until there is a reason to execute it. And the reason to execute is something called action. Coming back to the same concept of what is transformation, what is action. Transformation is something that creates a new data frame. Action is something that start calculating the result. It's a trigger to start calculating the result. The action is any instruction that forces Spark to materialize result. It's like telling a builder, okay, now go and build it. The blueprint is ready, go and do it. Until the Spark is happy to keep sketching. Some common actions are show, first of all, show, then collect, and then count. Show, collect, count, and write. These are only four common actions which we generally see, and each one has their own significance and where to use. We'll see in 1 or 2 minutes. But this is another diagram which I wanted to show, where we can see that whenever we are creating a data frame, Spark keep on planning and keep on creating the plan for newer data frames. So as I mentioned, every transformation would create a RDD or would create a data frame. Nowadays there is no RDD, so there is a data frame. So transformation would keep creating these data frames, and then action takes the result back. Transformations are operations that describe how data should change. They don't just execute immediately. The examples are select, filter, with column, group by. When you call them, Spark builds a logical plan, a blueprint that doesn't touch the data yet. And actions are the operation that demand output. They trigger Spark to actually run the plan, as I mentioned. Think of transformation as promises, and then action are the delivery. You can make as many promises as possible, as many promises as you like, but until there is a delivery to that, it's of no use. It's only after the delivery the results start kicking in. Let us see in practice. We have just seen few minutes back, but let us run it again. So as I mentioned earlier, in this the Spark has only prepared a logical plan that, okay, let me pull the data frame, then let me add a new column. The moment I add a new column, if let's say if my data frame is sitting in four different machines, how can I add the data set to it? How can I uh, compute these values again? So this type of plan is prepared, and after that, once we call for an action, the data is returned. Everything changes. Spark goes back to the very beginning. It reads the CSV, fills the missing values, adds the new column, and then finally print the rows. So this is how it works. The Let us now understand what are different actions possible and what is the significance of each. We have seen this simplest of the action, which is show. Show is something which shows the data, which is used for displaying the data. And Databricks is having a better version of show, is something called display. It is exclusive to Databricks, and we can, so show doesn't actually show in a very beautiful way, but what Databricks has built on top of that is display, which brings the data frame representation better. Right? You like the representation. This one is better than the old one, correct? So we generally use display, but in Spark program, whenever you are executing, you should use show. The most important tip is do not use show unless needed, because just for the sake of keeping, even if you keep show, you will waste the Spark memory inside. So sometimes what happens is people put debugging statement, use the show like a debugging statement, and then they also uh, like push the code with that, and then when the code start running on cluster and we start executing show, it will start printing the massive amount of data and your log files would be like flooded. So this is like an important tip. Then there is something called collect. Collect is again the same, but in case of show, the show just prints the data. Collect is something that brings the data back to the driver memory. So you have to be more careful when you use collect. There is always an issue that that a new Spark developer face, that a driver has went out of the memory and then they start increasing the driver size and all. But that is not the right way to do it. It is because somewhere in the code, let's say if you use collect and a huge amount of data start flowing towards driver, your driver would get out of the memory. Let us run the collect, and as I mentioned, this brings the data frame into Python. The list of objects are sent back to the driver memory. It's dangerous. It makes your driver fail. Okay, this is one of the most popular reason of why the drivers fail, driver failures. Then there is next one called count. You should use count also very carefully and only if needed. Um, so you can do that when you are interactively debugging or anything, but when you are using submitting the code to cluster, you should be careful when you count, because count would trigger all the actions. It would trigger everything and bring back the count to you. Okay. So let us do a small experiment in which what we are doing is we are just filtering. We are just filtering we are doing some transformation, and then we will not do the action and then we'll do the action. Let us see the difference of that. Let us just let's just simply uh, comment the action. So you see that, okay, it has only created a plan. So this is the plan it has created, and then what you simply do is you execute this, and action is taken. The result is shown to you. You will notice that before show, Spark just tells your schema. Show is actually something that runs and give you the rows. This experiment is the simplest way to feel Spark's lazy nature and why laziness is a good thing. At first, laziness might seem frustrating. Why can't Spark just run each step immediately like pandas? But laziness is a beauty of Spark. Internally, as I mentioned, you just simply put a method, but internally it has to prepare a logical plan. It has to prepare a physical plan and work upon massive amount of data transfers and clusters with billions of rows. So internally to do all these things, the lazy evaluation model works very well. By waiting until the last moment, Spark can optimize the plan. It can reorder steps, combine operation, or skip unnecessary work. Reduce data scan, it only touches data if needed. Save time, instead of running 5 separate steps, it runs one optimized job. So when Spark delays, it is not being lazy, it's in the bad sense. It's being strategic like a chess player, planning their moves. Today we learned about the Spark's most important principles. Transformation, build a plan but don't execute. Action triggers execution and then return result. Spark is lazy by design, so it can optimize your entire pipeline before touching data. As a fresher, if you wonder why just Spark didn't run my code, the answer is probably you didn't call an action. So this is the video of actions in Spark. Thank you for watching. We'll continue in the next video on something called Spark aggregations and grouping. Thanks, guys.